So this is going to be a quick video on how to calculate the perimeter and area of regular polygons. So let's begin by drawing my favorite regular polygon, the hexagon. So the hexagon has 6 sides. Try my best to keep it regular. Can already tell it's not going to be so good. And suppose this is a regular hexagon. You see it has 1, 2, 3, 4, 5, 6 sides, and any regular polygon can be broken down into triangles. So I'm going to draw inside this polygon lines that will break it up into triangles. And so this hexagon appears to be made of 6 triangles. Now each of these triangles has the same base length over here, and that's the case because we said that this shape is regular, which means that each side measures the same amount. So if the base, let's call this base over here, base. If the base has a certain length, and there's, in this case here, 6 of them, then the perimeter of the shape would be 6 times the base length, or side length. This would be the perimeter. But we don't always have 6 sides. Sometimes we have more, sometimes we have less. So the general formula would be perimeter is equal to n times base length, where n here is actually the number of sides. Let's do an example using this hexagon. Let's say that this hexagon has 2 centimeter sides. Well, in that case, the perimeter of this thing would be 2, which is a number of, not 2, but 6, which is equal to n, times the base length is 2, which is a total of 12 centimeters. That would be the perimeter of this hexagon. Alright, so let's grab all of this and shrink it, put it aside, shrink it, and toss it aside. Let's put it over here. And let's take a look now at the formula that we would use to find the area. So let's try to draw that hexagon again, this time a little bit straighter, and I guess in green, like this, something like this. And let's put in those dividing lines, something like this also. So I said that this hexagon could be divided into 6 triangles. 6 triangles because there are 6 sides. That should be intuitive, but as you can see, there's 1, 2, 3, 4, 5, 6 triangles, which matches the same number of sides. And it turns out that we know the formula for calculating the area of a triangle. All we need for this is the height of a triangle. So if this here is the height of this triangle, we've got this new name for this height now. This thing here is called the apothem, which means the height of a triangle inside of a regular polygon. So the area of this triangle would be, let's go back to the nice blue color. The area would be equal to the base, which is the base of this triangle, the bottom here. It happens to be the same as the length of one of the sides of our regular polygon. Base times the height, but the height we said is called the apothem, so I'm going to say base times a, divided by 2 because it's a triangle, but I've got 6 of these. I've got 6 of these triangles, but we don't always have 6 sides on a regular polygon. Sometimes we can have more, sometimes we can have less. So we'll say times n, where n is the number of sides. So if we want to do an example, we can say that this has a base length of 6 and an apothem of 4. In that case, if that's the case, then the area, let's make these centimeters. The area of this regular hexagon would be base, 6, times apothem, 4, divided by 2, because it's a triangle, times the number of sides, because we have 6 sides, that means we have 6 triangles. So times 6, and that's going to give us 6 times 4 is 24. 24 divided by 2 is 12. 12 times 6 is 72, and our units are centimeters squared. And that's the area of regular polygons.